Hello, everybody. I'm happy to be presenting to you guys today at this conference. I'm Ellie Symes, CEO of the B Corp. Our company is a US-based benefit corporation that empowers growers and beekeepers by delivering insights into beehive health. And before I get started here today, I'd like to give you an overview on our company. We were founded in 2016 with the goal of using analytics to better understand hive health. We spent the first year using temperature sensors to study the thermodynamics inside the hive, and in 2017 launched our first product, which used temperature sensors to let backyard and sideliner beekeepers know if their queen bee was dying. In 2018, we received a small business innovation research grant from the National Science Foundation to research and to develop how to use technology and data analytics to help commercial beekeepers. These R&D grants are awarded to small businesses in the US that are attempting to build innovation with significant technological and commercial risk, but that have a potential to positively impact society as a whole. Our grant was focused on proving the viability of using infrared image analysis to predict hive population from a commercial and technical feasibility perspective. After successfully completing phase 1, we were awarded a phase 2 grant to finish R&D on the product. Altogether, this National Science Foundation funding has brought in over $1 million in grant funding to our company. As a part of the SBIR grant, we conducted over 150 customer interviews to learn about the problem before building the technology. We found that a major concern for growers was renting enough strong hives to pollinate their orchards and secure crop production. We also learned that pollination contracts are priced based on the size of the colony. And to determine the hive strength, the grower pays for a manual inspection in addition to the hive rental fee. In these inspections, the hives are opened and the inspector estimates the amount of bees he sees inside. He does this by counting the number of frames covered by bees. We learned from our interviews that these inspections are inaccurate, meaning growers and beekeepers aren't getting a reliable estimate of hive value. They're slow and expensive, which means growers can only do a small sample of all of their hives rented, and they stress the bees out. So after the inspection, it'll take the bees 2 to 3 days to start pollinating again. That can be a big loss when some almond varieties are only available for a bloom for about 4 days. Our company is replacing these manual inspections using infrared imagery and data analysis to predict the size of the colony inside the hive. This is 93% faster than manual inspections, more objective and non-invasive, so no pollination time is lost. The images is captured with a camera that attaches to the back of any smartphone that we source through a hardware partner, and the colony size is reported back to the grower in an app. The B Corp team uses a detailed protocol to capture the infrared images accurately for the grower. We also, through our interviews, wanted to ensure the proposed solution also would help beekeepers. So easy to collect strength data allows commercial beekeepers to increase their transparency and reinforce growers' confidence in their business relationship by demonstrating the value that the bees provide. Beekeepers can also use this product as a point of comparison to other hives on the market, which they can use to justify higher prices during contract negotiation. Our customers want to use this tool to price per beehive, which incentivizes beekeepers to send the strongest hives for pollination and get rewarded for those strong hives through higher pricing. Data collected through Verify can be used to optimize the placement rate and distribution of hives for population. The recommended placement rate of 2 hives per acre for almond pollination comes from outdated research and should be updated for different growers' orchards as well, because it's going to differ across their crop varieties and their location. Granular colony strength data from Verify can be used to optimize this hive placement, allowing growers to enjoy fully pollinated trees and increasing the efficiency of hive drops for beekeepers. The map tool also allows beekeepers to identify exactly which hives need to be replaced in the orchards. And because we're 93% faster than manual inspections, beekeepers can reduce their labor time getting hives ready for pollination. This reduces their labor costs and allows beekeepers to focus on hive health. But you can't simply buy an infrared camera. Here's the same hive captured 8 hours apart, which visually looks like different sized hives. Our algorithm incorporates the complex ambient conditions that are needed to get an accurate estimate of colony size. Our hive strength model used by our product Verify was created by studying the infrared images of beehives, paired with population estimates and several other data points. We built an image recognition model to find the hive in each image and extract the thermal values for analysis. These values were used in testing our physics-based model that describes the relationship between hive thermodynamics and the bee population inside the hive. We built this model from the ground up. It was an iterative process where we would conceptualize, design experiments, and test whether new ideas and complexity improve performance of the model. We took into account ambient, biological, thermodynamic factors in our modeling to better understand heat effects not caused by bees and those caused by bees. We conducted large-scale pilots for the last 2 years as well to demonstrate the viability of our product in a real-world setting with a potential end user. With several potential end users, all while backing up our infrared image inspection with a manual inspection to ensure accurate reporting. During phase 1 of our grant, we proved the technology is viable and the infrared data can be used to accurately calculate colony size. We also demonstrated market demand and commercial viability for the solution, all which was important for our phase 1 grant objectives. Through our test, we determined the necessary improvements for our National Science Foundation phase 2 grant, and these improvements get us to full commercial scalability and viability. We were awarded phase 2 last year, so we're currently working on these improvements, which include refining accuracy for next pollination season so that the infrared images can stand alone, and adding additional software features that were requested by our pilot growers and customers. We're also working on onboarding new growers, beekeepers, brokers, and inspectors to the service as well. I'd like to thank Jerry and Frank for organizing this event and everyone else who was involved, and the opportunity for us to present, and our partners for their help over the years. If anyone has any questions or follow-ups from this presentation, we would be happy to chat. I've included our website and email here for any follow-ups. Thanks again, and I look forward to watching the other presentations.